All right, welcome back to lesson 103. All right, so today should be Thursday, I think. Something like that. Today's lesson is actually not that hard. I'm going to explain to you how it's not that hard. It's just super difficult. But, sometimes you have to deal with those in life. Just kidding. It's not that hard. It's not super difficult. So we're going to just do this lesson, and then you'll see how what I'm talking about is true. It's not that hard. For one part, for the other one, thank you very much. I know you love this video, that you can't wait. Probably the best part of your day after, obviously, hopefully praying to God and reading His Word, and maybe if you're praying with your family, that's a great time too. But I'm talking about the entertainment based, okay? This is not just a learning channel. This is an entertaining channel as well. Obviously, you just can't wait for those videos to go up and watch them. We all love them, right? And so let's get into lesson 103, dividing radical expression. So this is the first example, all right? So we have square root of 7 over 3, or 7/3, and some people are going to be like, wow, this is super crazy, this is super hard. So the first question I have to ask you is, could you divide by a decimal? And the answer should be no. You can never divide by a decimal if you have a fraction. So you can never really, no, you can divide by a decimal. That's not what I was really trying to say. What I was trying to say is, if I present to you a number as a fraction, right, and the denominator is a decimal, can I have that? No, you cannot have that. That's not what we usually do, because a fraction can be switched into a decimal, and a decimal can be switched into a fraction, but you cannot have both. It kind of is weird. We don't do that. So think about that as square root, because what is square root of 3? Square root of 3 is going to be a decimal. So could you have a decimal in the denominator for a fraction? Short answer, no, you can never have it. So why am I referring this to that? Because this question is really saying this. Square root of 7 over 3 is the same thing as square root of 7 over square root of 3. Could we have square root of 3? No, we cannot have square root of 3. So what do? What we do is we multiply by 1. But pay attention to how this 1 looks. Okay, I think I actually explained this last year too. Not sure, in 8th grade? Maybe I did. Maybe I didn't. So this 1 is going to be seen as square root of 3 over square root of 3. Square root of 3 over square root of 3. Okay, so then when you multiply, it's going to be square root of 7 times square root of 3, which is square root of 21, over, what is square root of 3 times square root of 3? It's going to be square root of 9, which is going to be 3. That's it. I finished my problem. That's all. So what we're trying to tell you is, never have a square root in the denominator. Simplify it so it looks something like this. Okay, so that was example 1. If you remember example 1, which you should, I mean, you were just watching it. And if you paused it for some reason and then just started watching this section by itself, then go back and double tap to the left in your phones, and it would just go back. Or if you're doing it on a computer, then obviously scroll down, scroll back, just track the thing down. But do something so that you could look at it again. But this is very similar to example 1, because as we discussed, this is the same thing as square root of 5 over square root of x. So we have to multiply by square root of x over square root of x, so that we don't have a square root in the denominator. And square root of x times square root of x is x squared. Well, what is x squared, or square root of x squared? Square root of x squared is x by itself. Wow. And 5 times square root of 5, not 5. Square root of 5 times square root of x would be square root of 5x. Can you simplify this x with this one? No, you can't, because this one is inside of the square root, or the radical. This one is outside. Okay? So That's my answer. That's all there is to this example. All right, in this example, which is the last one, I have to dive a little bit deeper. But then to be able to do that, we have to find the prime factorization of 72. 72 is the same thing as 8 times 9. 8 times 9 is 2 times 2 times 2 times 3, because this is 8 and this is 9, times x, times x, times x, times x. Boom, look at that. Yeah, I know that some of you are factorization masters like I just did here, so I know that none of you are impressed. So then we have 3 times 4 times 5, which is the same thing as 2 times 2 times 5 times x times x times x. So the reason we're doing all of this is so that we understand, oh, okay, so in here I can get 4, because square root of 4 is 2, and I also can get square root of 9, which is 3, so 2 times 3 is 6. Well, look at those that number math right there with the fingers. And then we have x squared and x squared. X squared and x squared is going to be x squared. Square root of x squared is x, like previous example. And square root of x squared is going to be x. So in here, we're going to get, let me just do it right down here so that you understand. So in here, we're going to get square root of 4 times square root of 9 times square root of x squared times square root of x squared times square root of, what am I left with? Just the 2, okay? I know why I put it that way, okay? You will see in a second if you haven't seen yet. And then in the bottom, we have square root of 4, which is 2, and square root of x squared, which is x. So we're going to have 3 times square root of 4 times square root of x squared times 5, square root of 5, times square root of x. Yes, I believe that's it. Because in here we had 3 x's, here we had 3 x's, we had 2 4s, and all of that jazz. So square root of 4, 2, square root of 9, 3, 2 times 3, 6, as I had demonstrated with my fingers before. And then x squared is going to be x, and x squared is going to be x, and x times x is going to be x squared. Wow, crazy. And then all of that over square root of 2. Not over, but times square root of 2. Whew, not over. Over is going to be here. So then we're going to have 3. No, let's not put the 3 down. Oops, erased a little bit too vigorously right there. So 3 times square root of 4 is going to be 2. 3 times 2 is 6. And x is going to be 6x. 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 Very successful. All right, and so in here we have to then get rid. It's not the virus, I promise. In here we're going to have to multiply by square root of 5x over square root of 5x. All right, so when we multiply this, it's going to be 6x squared square root of 10x over 6x times 5x. Let's cancel out right now. I'm going to cancel out the 6 with the 6 and this x squared with this x squared. So that I'm left with square root of 10x over 5. Let's check. What do you know? Square root of 10x over 5. That's the answer. So please remember to prime factorize. Then, after that, get everything that you can out of the radical. The radical is the square root sign. And then multiply it together. Then multiply everything that's outside of the square root together. Then multiply by whatever square root we have in the denominator. And you get the answer. So this is actually really easy, but you have to keep track of the numbers that you have. All right. So this is it for lesson 103, which is the lesson for Thursday. Let's do tomorrow's lesson. Well, not in this video, but in the next one, which you will see it's a little bit more in depth, and I hope it's not as long, but it's going to be a new concept that if you haven't learned how to do factoring really well, factoring of trinomials, all right? So what we've been doing for a long time already, we had about 6 or 7 lessons of it. You have to learn how to do it well, because tomorrow's lesson has to do a lot with it. So I will see you in that one. And if you haven't had a chance, then go review it.